Okay, this problem is called add two numbers. Let's begin. So you're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. Okay, so so basically you're given a two linked list. Alright, so for example, first one is like this, the second one is like this. And you essentially add them together. Alright, so you've got 7 here, you've got 0 carried, and that will essentially give you 7 plus 1, 8. So you get something like this, basically. But what you want to do is have them be returned after adding all of these node values as a new linked list. So you return a list node, basically, whatever your list node is, right? Your resulting list node. Okay. And yeah, that is the gist of the problem. Okay, so let's begin. So one way of approaching this problem is definitely just to traverse the list node. Alright, so to traverse the list node, you just check whether there is still an existing node. That's one way of doing it. Okay, so say either case, we still wanna traverse it. So let's say this right here has 3 nodes, but this right here only has 2 nodes. In this case, we still want to traverse it and then add it regardless. Okay. So we need to store the node somewhere, the values of the node. We can create a dummy node first. Alright. This is just making it easier for us to reference of all the nodes that we're going to add to the next of the list. This node here. Okay. Next. And then I'm gonna traverse over. Next. Okay. We make this an optional because then as we traverse, it's possible that we're going to hit a case where we no longer have any value to add, which is when we end. Okay, we also need to take care of the carryover case. Carryover, put a 0 here. About 10. Yeah, so basically if we divide it by 10, we'll get the last digit for the carryover. This should be the carryover. Right. And so by 10. So what we can do here actually append the carryover. Okay. So okay, so yeah, let's give this a run. Next. And also while we still have a carryover, you wanna continue with the traversal. Next. And of course we need to traverse the list node. Okay, gotta do some changing of the variable names here. Okay, so the answer here is wrong. So let's see where the mistake is. Let's do some print statement, making sure that we have the running sum correctly. Okay, I think the addition is correct, so that is good news. Now let me just make sure that the carryover is also correct. Okay, so we don't have a carryover, so that is not ideal. I'm thinking maybe it should been this. Maybe I have the string mixed up. Let's try this. Okay, this looks much better now. Node, this node, running some. No, where am I making a mistake here? What am I missing here? Okay, let's see, current node equals dummy, not next. Oh yeah, see, dummy dot next is new, so maybe just set it to dummy. Here. Okay. Carry over. Okay, we're making good progress here. And okay, for the carryover, I'm running some. We should do a modular of it. See if this works. Okay, that looks good. And then carry over. Go running divided by 10. Okay, yeah, there you have it. Yeah, so this is how you can go about solving this problem. Of course, you also saw that, I wasn't like the most familiar with this problem, but I think that's okay. That's why we practice, and yeah, we just get more used to it. It's not like we work on this kind of problems every single day, so yeah, just if you really want to get good at it, just more practice. But you also saw my thought process and how I went about debugging the problem as well. So I guess that is also a benefit of this video instead of having it super perfect. And okay, that's it.